Right, so we have this function, f of x equals negative x cubed times x minus 2 quantity squared times x plus 2 quantity squared. And we want to sketch the graph of this polynomial. Right, so the first thing we want to do is we want to get the degree of this polynomial here. Okay. Remember, degree is important because it's going to tell us the end behavior and what the graph should be doing at the ends. Right, so what we need to find degree, right, we just count all the different factors, right? Now you notice that there's 3 different factors of x, right? But we also have to count the powers as well, right? So there's essentially 3 x's, so it's x times x times x minus 2 times x minus 2 times x plus 2 times x plus 2. And that's going to happen 7 times here, right? So 3 plus 2 plus 2 here, that gives us 7. So we can conclude that this is going to be a 7th degree polynomial. Okay, what are the zeros or the roots? Okay, so we want to set each factor equal to 0 here. Okay. Now, for all intents and purposes, we can just regard the negative. That's going to be important later on, right? But we're just going to find the zeros now. So we'll set each factor equal to 0. Okay, x equals 0, x minus 2 equals 0, and x plus 2 equals 0. And obviously, x is just equal to 0, right? But what is the multiplicity here, right? Here the multiplicity is 3, right? Because it's essentially x times x times x. Okay, here x minus 2 is equal to 0, then x is equal to 2. But once again, this multiplicity is 2, right? It's even. It has an even multiplicity. And then finally, if x plus 2 is equal to 0, then x equals negative 2. And similarly here, that multiplicity is 2 as well. So what we want to do now is use the degree to determine the end behavior, use the zeros and the multiplicities to draw the final graph. Okay, now remember, this is just a rough sketch, okay, so it's not going to be like exact, okay. So first thing we should do is get the end behavior, okay. Now this is a 7th degree polynomial. It's an odd polynomial, which means we're going to have a little S shape, right? Okay. But it's negative as well. So that means it's going to be flipped around. So that means we're going to go up and to the left, okay, up and to the left, and down to the right. Okay, because it's an odd polynomial, but it's negative. Okay. So we're still going to have our S shape here, right? Okay. So now what are the 3 x-intercepts in this case? Here we get negative 2, we get 0, and we get positive 2. The last thing we want to do is actually draw the sketch, right? So as we approach the first x-intercept, right, as we approach negative 2, what's going to happen? Are we going to go through it, or are we going to touch it and bounce back? Okay, well, the multiplicity is even, so we're going to touch it, bounce back. 0 is the next x-intercept, so we're going to have to turn around at some point. Okay. But then at 0, are we going to go through it, or are we going to touch it at 0 and bounce back? Right? The multiplicity tells us, right? It's odd, the multiplicity. So because it has an odd multiplicity, we're going to go through the x-axis. Here's the next x-intercept, so we are going to have to turn around at some point. And what's going to happen at 2? Well, at 2, the multiplicity is even, so what can we conclude here? Right? Because the multiplicity is even, we're going to touch the x-axis at 2 and then turn around, right? Remember, everything has to sort of match, right? So when I say that, what do I mean? Look at the end behavior here, right? So we're not going to turn back around and go up, right? Well, first of all, there's no x-intercept, right? So there's nowhere else that we're going to touch or cross the x-axis. But also, based on the end behavior that we determined, the graph is just going to go like that. So we do have our, once again, we do have our S shape, but it's sort of flipped over. Okay? So at negative 2, we touch the x-axis and we bounce back. We turned around, we approach the next x-intercept. In this case, we go through at 0. Then we bounce back, we turn around, and then at the next x-intercept, the multiplicity is even, so we bounce back, and it matches up with the end behavior. So here we go, right? We have successfully graphed this polynomial function.